Hi, everybody. Glad you're a member of Sign or using this opportunity to visit Sign Calibration School. This is a video introduction to our technical paper of why a 4-to-1 TUR is not enough, the importance of analyzing the probability of false accept. I hope everybody has a chance to download this paper. What it talks about here is we're talking about TUR, and when we start looking at TUR, we're looking at tolerance divided by the calibration process uncertainty. Here's an Excel sheet which we created, and really we're talking about risk. This sheet does a lot of different things with risk. So in this situation that I have here, I have a 10,000 pound load cell. Resolution is zero point 0.1, and my instrument reading, which is very important, is the location of the measurement. So what we're showing here in this sheet is the TUR, the importance of analyzing the PFA. TUR is test uncertainty ratio. What we're really showing here is a risk analysis tool that says, what do I need to be in to have risk less than 4% overall, or to assure less than 2% risk on each side. And that's really looking at this curve here, and we're looking at the guard band down here. We're looking at the guard bands, and depending on what we're using, if this instrument walks in the door with this, we really want to get the repeatability, which is a series of measurements to this. So say this instrument walked in the door, we type in the repeatability here, 9999.2. And to really get repeatability, we want to have more than 2 measurements. Ideally, 5 or more measurements would be good. But you can see the standard deviation here at the bottom is not changing too much with these measurements, because I'm typing in mainly the same numbers, and I can type in a little bit different here. So I typed in numbers, say I recorded all these readings. The average of these readings was what we want to kind of put in here. It's 9999.3, and I look at the side. This tells me if my standard, Morehouse standard, 16 parts per million, this tells me that to make a statement of compliance, that if I want 2% risk or less, that my number has to fall between 9995.245 and 10,004.755. If I just subtract the uncertainty only, this is what the number's gonna fall in between. But I want less than 2% risk. That's what we want. So this sheet shows that. The paper is going to discuss it in more detail. If I switch, what I just did here is I switched from CMC of using dead weights to a lab that's using secondary standards. What I did here is when I switched this number, it shows that my risk went higher than 2%. It actually went to 4.28. So it really shows the importance of the reference, the lab, the uncertainty of that reference and calibration. Nothing else has changed, but if I switch from dead weights to secondary standards, my guard band right here, my limits switch dramatically. Now I have a lot less to be in. And if I'm not within this 1000.13 or 999.862, I'm going to have to say, hey, my PFA is going to be, my probability of false accept is going to be greater than 2%. My risk is going to be greater than 2%, and therefore I cannot pass the instrument when you are asking for a statement of compliance or a statement of conformance. In this situation, since my risk is more than 2%, I can't pass that device unless the customer specifically says they're okay with it, and they have to analyze the risk. So the total risk with dead weight here is, this is dead weight here, is 0. Total risk with secondary standards, the same device, is 5.42%. So I hope the paper gives you more of an insight of what's going on. I look forward to, if you have any questions, please email us at info@mhforce.com. But happy reading, enjoy the paper, pay attention to the location of the measurement, pay attention to risk, and pay attention to why just requesting a 4-to-1 TUR is not enough, because we really want to analyze, back to this, we really want to analyze the risk level and make the decision based on minimizing that risk. Thank you.